Okay, this is section 6.3 where we're adding and subtracting radical expressions, and all of our radical expressions are going to be like radical expressions in this first couple of examples we're going to look at here. So we're essentially looking at 6.3 day 1 activities. A couple of things. When we add and subtract radical expressions, again, when we add and subtract radical expressions, you can combine like radicals using properties of real numbers. So essentially, you'll notice here, if I have the square root of 2 plus 3 square roots of 2, that's 4 square roots of 2. Now remember, if there's nothing in front of that number, there's always a 1 there. So essentially, 1 radical 2 plus 3 radical 2 is 4 square roots of 2. Okay, it's very similar to adding like terms. For example, if I have 3x plus 2x, those are like terms. The x's are like terms, so I can make that there's 5 x's. Now, if I said 3x plus 2y, can I add those guys together? No, I cannot, because those are not like terms. When you're adding radicals and subtracting radicals, it's all about being able to find the same root and the same index. Okay, so when you're adding like radicals, the number underneath has to be the same and the index has to be the same. If they're not, you cannot add those together. So for example, here we have the cube root of 7 minus 5 cube roots of 7. Okay, numbers underneath are the same and the indexes are the same. So this, again, there's a number up front, always is 1 if there's no number there. So in this case, if I take 1 minus 5, that's negative 4 cube roots of 7. Okay. Same other examples over here. I have the square root of 5xy plus 8 square roots of 5xy. Now again, if you look underneath the radical, it's exact same numbers, and the indexes are both 2. So I can add this 1 plus 8 gives me 9. Okay. Now, what happens if I have, like, in this case, 3 square root of 2 plus 2 square root of 3? Okay. So now, as I'm looking at this example here, square root of 3 and the square root of 2, now as you look, indexes are the same, but the numbers underneath are not. I cannot add those together, so I simply just leave this the way it is. Okay? Alright, so again, roots must have the same index and the same number underneath the root in order to be able to add or subtract them. If they're not the same root, or their number underneath the root's not the same, then you cannot simplify it. You just simply rewrite it down. Sometimes you'll have to simplify roots first in order to combine with addition or subtraction. This part we'll talk about in the second video. Okay, but for right now, everything's going to be simplified already for you. It's just a matter of being able to find the correct ones to combine. Okay, so look at your examples here on the very first sets of notes. We're going to go through the very first 2 sets of examples. So in this case, let's take a look at example number 1. We have negative 3 square root of 2 minus the square root of 2, or again, 1 square root of 2. All right, so what I look at first here is the number underneath the root the same? It is. And is the index the same? They are. So because these numbers are the same and the indexes are the same, I combine them just like terms. So negative 3 and negative 1 is negative 4. So this becomes negative 4 square root of 2. No different than if I said negative 3x minus 1x. You would say that's negative 4x. Very same concept. You treat roots just like variables when you're adding and subtracting. Second example. Now, in the second example, you'll notice that we have a couple different things. Okay, we've got some addition, some subtraction of the same problem. But I've got 2 square root of 6 minus 2 square root of 6 minus 3 square root of 5 plus 2 square root of 6. Okay, so essentially what this is very similar to is combining like terms. And what I need to do is find my like terms. Well, I know I have, as you see here, these numbers are all the same underneath and their indexes are the same. So these guys right here are all like terms. So I can add or subtract them. Well, 2 square root of 6 minus 2 square root of 6 is 0. plus 2 square root of 6 is 2 square root of 6. And then I bring down the 3 square root of 5. Okay, now, can I combine these two? No, because this right here is a 6 and that's a 5. Those numbers are not the same. This is my simplified answer. Okay, again, if I were to write this with variables, this would be 2x minus 2x minus 3y plus 2y. And again, I got plus 2x on the back end, not 2y. All right, so now here, these are all my like terms, no different. These guys would cancel out, and I would have 2x and minus 3y. No different than what I got there, except now it's just a root instead of a variable. Okay, so you should be able to complete the first page here of examples on your class kick.